Can gravity exist if space-time were perfectly flat? It sounds like a technicality, a question for a textbook, not the universe. But the answer changes everything about how we understand falling, orbiting, and being pulled toward the Earth beneath your feet. Because the honest answer is no. Not gravity would be weaker, not gravity would behave differently. Gravity simply would not exist at all. Newton gave us a gravity that worked. It sent rockets to the moon. It predicts tides today. But Newton's gravity was a force with no explanation. Mass pulls on mass, instantly, across empty space, for reasons Newton himself admitted he could not explain. Then, in 1915, Einstein replaced the force with a shape. Mass and energy don't reach out and pull. They bend the space and time around them. And everything nearby, planets, light, falling apples, isn't being pulled at all. It's simply following the straightest possible path through a surface that is no longer flat. Here's the part that breaks intuition. Objects in freefall are not accelerating. They are doing the closest thing to nothing that physics allows. On a flat surface, doing nothing means moving in a straight line. But on a curved surface, the straightest possible path is called a geodesic, and geodesics can look curved from the outside, even though locally they are as straight as physics allows. An orbiting satellite isn't fighting gravity and losing, it's tracing a geodesic through curved spacetime. A ball you drop isn't being yanked downward, it's following the straightest line available in spacetime that Earth has bent. Remove the curvature, and there's no reason left for anything to move at all. This isn't philosophy. It's been tested repeatedly for over a century. Mercury's orbit drifts in a way Newton's gravity could never fully explain. Einstein's curved spacetime predicted the drift exactly. In 1919, astronomers watched starlight bend around the sun during a solar eclipse. Light, with no mass, still following the curve Einstein described. And in 2015, we detected gravitational waves, ripples in spacetime itself, from two black holes colliding over 1 billion years ago. Not ripples traveling through space, ripples in space. Spacetime itself, stretching and compressing as they passed. None of that makes sense if spacetime has no shape to ripple in the first place. So picture that flat universe from the question. No curves, no dips, no warping around mass. Every geodesic is just a straight line, forever, unchanged. Planets wouldn't orbit stars, they'd drift past them in perfectly straight paths, completely unaffected. Light wouldn't bend around galaxies. Time would tick at the same rate everywhere, for everyone, always. Apples wouldn't fall. Moons wouldn't circle planets. Galaxies wouldn't hold together. Not gravity would be different. There would be nothing there to call gravity in the first place. Gravity was never a force reaching across empty space. It's the shape of space-time itself, bent by everything that has mass or energy. Every orbit, every falling object, every ray of bent starlight is geometry, written into the universe and followed exactly. Flatten that geometry and you don't get weaker gravity, you get a universe with nothing left to fall.